Okay, this is a follow-up video to a video I did. I'm showing here a video I did a while back in October of 2020, when I was showing off a Power App or the use of a Power App that I was creating, and the what the Power App did here was it took a set of data from either Excel file or somewhere else where you have a set of 2 by 2 data, and the goal was to visualize this by turning it into a 3D object. So that's what you're seeing here. Is you're seeing some sliders that are for adjusting things like the start and end color, the height of this data set when it's visualized. In this case, a 4 by 4 grid. And so the way this worked was, let's go ahead and scroll to the end here where I talk about the pieces that are involved. But the data in this case came from an Excel file that was stored in OneDrive, and I used the OneDrive data connector in Power Apps to access that data. And then I took the data and I sent it to an Azure function to generate a 3D model from data. And then I created a custom data connector, which is the way I was able to connect to that Azure function from the Power App. And then I used the result 3D model to visualize. And so that's what you can see here is the visualization of that data. And then pulled that into mixed reality as a final step. I think that's here. I'll go ahead and play that, where I'm actually rotating that final 3D model. Again, that's data that comes from basically a 2D array. And so as part of that, I kind of, I guess, did a little bit of hand waving on this idea of that middle section, Azure Function that generates a 3D model from data. And so I had someone ask about that piece in particular. And so I wanted to show off and maybe talk a little bit about how you might go about building an Azure function. The cool thing about Azure functions is that they are stateless. They can you can just have a function that exists in the cloud, basically a program that's running. You send in some data, it sends some data back. That works really well with like a REST call, like a REST web interface. There are some ways to save state, but what I was interested in particularly was the ability to send some data without any state, and then send the result 3D model back, and then you're done. And then the next one would be basically a fresh start, which is kind of cool. So if you've done any work with REST web calls, what you know is that there is basically it's an HTML call, like an HTML post call with some data and any kind of really interface for calling REST calls is really best tested using an app called Postman. Postman's free, and what's really great about Postman is you can kind of you can imagine a web form where you might have various fields that you're filling out and you're sending as a post or a get. You can actually set that all up, set up your headers, send that data over to your whatever the website is that is returning values, and then get the results back. You can use this for things other than REST calls, but REST calls is particularly useful for because you can actually inspect the headers. In this case, looking at my headers, I have got, I'm just using the default values here. I haven't changed anything. The real interesting part is in the body, and the body I'm sending, just a set of paired values: width, height, z-scale, min and max color, whether or not there's a return file, and the actual data itself. In that width, height, the expectation is that those values are the actual width and height of the data array. And so I've got some error checking to make sure that that's the case before I try to process it. The z-scale is how high that 3D model that's created ends up being. And the min and max colors are the difference between a 0 value, what color is that in the grid, and 1 value, what color is that. So this is a RGB color scheme. So from red for a 0 value, and a max value is going to be blue. And of course, I want to return a file. So just to give an example of this not working, if I have this set up with a height of 5, and then I click this send, it's going to come back and say, hey, look, the input data length is not a product of width and height. That's a requirement. It's going to give me this argument exception. because one of my arguments is incorrect. So I need to change this to be 6 here, because the data that I'm sending over is a 6 by 6. There's actually 36 numbers there. And there's just some ones and zeros. There's really no rhyme or reason to this. I was just throwing in some values just to demonstrate what this might look like. I kind of like values that start off with 0.0 on the edges, because then you get a nice 3D model that's got kind of everything at the edges, zero values. But let's go ahead and send that. And now with the right values, we get a response here that's actually what we would expect. So it's a GLTF file, which is what's created. Which is I've got a separate video that describes how GLTF files are formatted. But basically, the important thing to note is it's a bunch of text that it's actually not text. It's a combination of text and binary data, but a good chunk of it is ASCII values, so you're able to read it in human form. So starts off with that every GLTF file starts with this GLTF magic number, which turns into the ASCII letters GLTF, and then you've got basically a big JSON array here of ASCII data, and then there's some binary data, and the binary data is where the meat of the 3D data is, basically arrays of binary values, arrays of vectors, arrays of normals, and then the JSON data basically tells you how to go through that binary array and extract useful information out of it. And again, I've got a separate video that describes this in detail. The video is like an hour long, but I do go into quite a bit of detail of how 3D files are stored, and in particular how GLTF store their data. And that actually, it was this project that allowed me to create that other video to describe just in detail how this works. So enough of this. The last part you need to know is that when you're using this, like I actually want the GLB so I can save the response here. So I can save that to a file. And so I can say, okay, test.glb, and that's going to save the file. I can also do this here where I do send and download all in one step. And so let's call this test2. It's going to be the same file response. So let's go ahead and change some of these values just so we can see that it actually works. Let's change this from min color to let's do blue at the bottom level, and we'll do white at the highest value. So it should have blue at the base, and then white at the top, and then maybe change some of these values to show that they're slightly different. Maybe some 1.0s. It doesn't really matter. And then send that, and then let's call that send and download, and call that test3. So we're really looking at the difference between test 2 and test 3. So let me pull up. Let's pull up this this folder here, this GLB folder. Let me go ahead and open that and pull that over here. And you can see this here. I've got these files, and I'm going to open this GLB using, let's use 3D Viewer, and pull that over here. It's opening up, and you can see this is that red to blue file. And then if I pull the GLB3, whoops, not in text format, but using the same viewer, you can see that's again slightly different, but now it's blue and white versus the other one, which was red and blue data in there. Again, this is the kind of thing, again, 1.0 and 0.0 values that are in that graph. So that's what this does. And so now we have to switch over to the Azure function, and there's many ways you could write an Azure function. There's web interfaces. You could use VS Code. In this case, I'm using Visual Studio, and a bunch of the cool thing is a bunch of this is built into Visual Studio to just kind of work. So let me pull this over. Once you're logged into your account in Visual Studio, you can actually be logged into your Azure account, and so this is all integrated. It can take a couple steps to step this up or to get this set up. You can get a free account. I think I've got a set of a step-by-step screenshots I can walk you through here in a minute that demonstrates that. But what I want to do now is demonstrate the actual file that we're looking at here. So what's creating that function. And this starts with this function called create graph. And if you remember looking back at that URL, it was the URL was the website dot or slash API, I believe it was API slash graph. So the graph, this route value here is that graph value in that. Let's bring up the Postman, this part here. So we've got slash API slash graph. And the way it's resolving that is through this route here. And it's basically saying this is an HTTP trigger, create graph. And that's the way we're making that mapping of, hey, this is the function I want to call. And it starts off with, awaiting the stream reader to read to the end of the async. So we're reading the request body is what we're doing right here. We could be looking at the header, request.header, but this is request.body, and we're putting that into the string request body. And we're going to try to deserialize that object. So we're going to convert that JSON, which is what it's coming over as, into input, and then we're going to look at our input and do some error checking. So the first thing, make sure we've got actually good input. And as we start reading through that input, the width, the height, and should be a function of, well, the width and height has to be greater than 0, it has to be less than 100 for my purposes. I didn't want to go too crazy on this. And then I need to make sure that the data that is included actually is greater than 1 is what it needs to be. If it's 1, it's the same as being null in this case. And then if it's not null, let's check to see that the width and the height multiplied together equal the length of data. So if we got 6 by 6, there should be 36 values there. And if not, then we get this input data length is not a product of width and height, which we saw that error message earlier. Okay, so we've got that. And so then we actually get to the, okay, let's go ahead and create a new GLB. And we've got a byte array. And so we're going to start building up this byte array of data. So let's go ahead and dive into the write GLB, which is what is that does the work of taking the values. So the data here, data 2D, min color and max color and a z-scale, and converting that into a 3D model. So go to that definition, and so we'll get the length and get the height, and we need to just create this array, flattened array of floats. And we're going to start with that flattened array of floats and go by width and height and create this basically flattened data. And we're going to write that to our write GLB. And once we have that, set the min and max if they're null. Otherwise, let's go ahead and set those values. And we'll start building that GLB file. So we've got this magic GLTF. You see this resolved to 0x 46546C67, which is basically the ASCII equivalent to under lowercase gl capital TF. As you saw, that's sort of the magic GLTF number. And then so we then have similar magic numbers that we include in this text file, or this binary, which is text readable file. And then we go, if we don't have any data, I want to generate some sample data. So I've got some basically it creates a bunch of random data if you haven't sent any into it. So this part here is a little bit, I can't remember why I did this, but basically I've got a situation here where if the data is not as a 2D array, I can make it 2D. So instead of having, a single, where I've got to do j times width plus I can actually convert that to an I comma j. I don't remember why I did this. It seems like you do this in process, but whatever. It's what's happening here. So once we have that 2D array, then we can actually get into the meat, which is in this generate grid from data source. This is where we're actually doing the real work of converting that data into vertices, colors, normals, etc. So the first thing I'm doing here is I'm lerping through that the width and height to create a height map from a set of vertices, right? We've got some colors that come as part of that because we're using vertex colors. And then once we've got the verts and the colors, we can then generate the normals. I think here I'm doing basically, crossing the two vectors to find a orthogonal vector that represents the normal. And then once I've got that, then I can go and build triangles out of the vertice data. And again, kind of lerping through or looping through to create, like I say here, a 10 by 10 grid should have 162 triangles, which is 324 vertices, right? So you can see that I've got a little cheat sheet for myself there where I describe like what an actual triangle would look like. And so using clockwise rotation of 1, 2, 3, and then 1, 2, 3 to make each, you see the top and the bottom there represent, an actual square made up of two triangles. And then we get to the point where we can then just create that index array and we're good to go. And that's it. And so then if we go back to where we were at, we've now got this data filled out and we need to dump that into our buffer. And so we've got these buffer views of indices. We've got our buffer views for our verts and our normals. We've got nodes. And again, this is all described in detail in the other video. Accessors are the way you actually access the data that's in those buffers. Again, that's also in that video. But these are all just the way a GLTF is put together. We've got some materials that need to be created. And then finally, we need to convert the JSON. So we need to build this JSON link back. I apologize for all my commented code. And then now that we've got that, we need to then create the resulting array by creating an output stream. And so we've got this memory stream. We grab our bytes from our magic numbers. We need this needs to know part of the definition for a GLTF is not just the magic number, but it needs to have a version number and it needs to have know how big this thing is. And so we have to include both the length as well. I believe that's just the head length. And then there's the chunk lengths that need to be generated. So this is all, again, described in great detail as to the GLTF definition. But that's what we're building out. We're building out all of this data, and we'll switch back over to the end result here in a moment. And then, if there's any exceptions, catch them, and then basically we're done. And so when it's time to actually publish this thing, you can. It's actually really easy. You go here to build and publish. So I know that's right off screen, but it's build and publish. Let's pull this over. Build and publish. And assuming you have configured your Azure function in your Azure account correctly, this just kind of works kind of magically. And so this brings up this screen. This is my data. I better make sure I've hidden that before I finish this video. But then I can just hit publish, and this takes a moment. And basically, it's doing the regular build process. And once I've already built this, so maybe it's going to build it. It's telling me a warning there that my target framework's off by a little bit. But then I think it's on 3.0 and it should be on 3.1 or similar. I'm using this Net Core 3.0. You can use the latest. I'm sure it's fine. But then it builds a package. It zips it up. It then pushes it to basically Azure storage. The function is now live. And now if I was to switch over to Postman, I should probably have made some changes so we could see it and happen. Let's do that. Let's actually go ahead and send this data. We'll do a query request. Come back and call this test 5. I don't jump one. But let's go back information, and then this is my actual return value. So this is the one I need to change into an exclamation point. Let's do that. Let's do 2 exclamation points just so we know what we're doing. I shouldn't have that redundant. I should actually be using the same text value, but that's fine. Again, this was just to prove a concept. So let's go ahead and publish this again in real time. Again, it sends it up to my Azure account, which is quite cool that it just kind of does all this for you. And then once it's done, okay, switch over here, send that again. Sorry, send it. It's available. I was a little quick on the draw there. Okay, and now there's the 2 exclamation points, right? So it shows that actually those changes are being read at real time from this Azure website. If there's any questions of that, feel free to reach out and ask. But I think the cool part of this is you can have your code running in the cloud. And you can query your code from any form. So theoretically, I could have a website, and these values were in the form, and I could have this as the return result. In fact, so I want to show the portal itself. This is showing that as part of the free services, you can use these functions up to 1 million requests per month. At the time of this writing. And so then you can use this Quick Start Center to build and deploy and operate a serverless app. You select the serverless event processing using Azure Functions. So that's one way to get to it. And then you set up your function information here, which ends up showing up in your Visual Studio. What's really cool here is that you can set what your development environment, whether it's VS Code, Visual Studio, or Develop Portal. I've obviously used Visual Studio, but there are other ways. And then when we get to this last screen, this is in Visual Studio. You can choose to pick from Azure, pick your Azure function, and then get to this last stage where you actually sign in and you have that account access. So it's actually really nice. This is all integrated to Visual Studio. You could either do it through the web portal or through Visual Studio itself, and just again hit that publish button, and your stuff's live.